we're being told, verify that the vector x, this vector, see if it's a vector multiplied by a scalar, but I can multiply this scalar by each component, is a solution of the given homogeneous linear system. Now, homogeneous, that's a good news. That means it's going to have this form over here. Remember the x prime ax? Okay, so the first thing we want to do is we want to convert it to matrix form. Then I want to show you how to do this in MATLAB. So let's go over to MATLAB and let's try to see how we would do this. All right, so here, MATLAB for exercise 17. So the first thing, I'm going to put a comment and I'm going to say defining my symbols. And you do that with the command sims, or sim. And what are my symbols? Well, we have that T, right? Now we're going to define my matrix A. Now remember that matrix A was the matrix that was right here, the coefficient matrix. So how do you define a matrix in MATLAB? Well, you have A is equal to, then you open the square brackets, then you type all of the first row, so that's 3, -4, put a semicolon to tell MATLAB that you're going to the second row, and then you have 4 and -7. Then we put another semicolon here so that we don't get the output over here because we don't want to see it. Then I'm going to define the solution that they gave us. What was the solution? Well, they told us verify that the solution works. And the solution, they called it x, is also a vector. Now I'm going to multiply that exponent by each term, or I don't even have to do it. I can just say 1 and 2. I put a semicolon after 1 because that was the only entry in the first row, and 2 is the only entry in the second column. And then I'm going to multiply that whole vector by the exponent of -5 times t. Now, exponent parenthesis means e to the. And again, I'm going to put a semicolon because I don't want it to output. And then I'm going to verify that the solution proposed is true. So we have to take the derivative of that solution because remember we had the derivative here, x prime. Then we set it equal, and you put the equal in MATLAB with a double equal. So double equal here. Then we have already defined this coefficient matrix as A. So I write A, and then I multiply that by my solution. And my solution is x. And then I don't put a semicolon because I want to see the output. And I want to see if the left-hand side is going to be equal to the right-hand side. Now here we have unrecognized variable t. Was it sims or sim? It was sims. Okay, so now we see the left-hand side is equal to the right-hand side, and so we know that this is a solution. And this is another way to do it without doing it by hand, which is not a big deal for this problem, but if you have a bigger solution, then you might want to use MATLAB to avoid careless mistakes. I hope this was useful, and I'll see you next time.